I did.
Are you going to record this?
So find the value of c guaranteed by the mean value theorem for integrals for the functions over the given interval. If we go back in time to find f of c, now they said find the value of c, but we know f of c, this is the mean value theorem. The average mean value, or the mean value theorem, I didn't say average mean. That's the 1 over b minus a of the integral from a to b of f of x d of x. So f of c equals 1 over, so I need you guys to help me out here, pi over 3 minus negative pi over 3 would be what? 2 pi over 3? From negative pi over 3 to positive pi over 3, f of x cosine x d of x. Still okay? So f of c equals, how about 1 over 2 pi over 3? Isn't that 3 over 2 pi? Let's think of it that way. And then let's go ahead and take the antiderivative of cosine, which is sine of x from negative pi over 3 to pi over 3. So we're going to put 3 over 2 pi times, okay, you guys are better at this than me. What's the sine of pi over 3? So square root of 3 over 2 minus, what's the sine of negative pi over 3? That would be negative square root of 3 over 2, wouldn't it? So that becomes plus plus. So let's see, square root of 3 plus square root of 3 would be 2 square root of 3 over 2, which would just cancel to give me square root of 3. So now f of c, I'm going to have to come over here to the right, f of c equals 3 square root of 3 over 2 pi. What did I ask for? Find the value of, now all we do is we say cosine of c equals this. Grab your calculators. Make sure it's in radians. How do I get c? I take the inverse cosine of that. So so I'm going to take the inverse cosine, the arc cosine, of this. Everybody's crunching it. 3 square root of 3. So everybody take 3 times square root of 3, enter, divide it by 2 pi, hit enter, then take the inverse cosine of that previous answer. Okay? Let's crunch it. Three decimal places. Ari, what are you getting? 0.597. Do I have an agreement on that? Anybody else getting that? And I bet I have on the next screen the... Okay, whoa, why is there a negative? Look at my interval. My interval is from negative pi over 3 to pi over 3. Guys, think about it. A, smart, trig, class, there's another answer in that fourth quadrant. So that's why it's the positive and the negative 0.597. Let's stop. Does that start ring? That was how we started this unit, with that web assign doing those. We okay? I thought the work be still there. Apparently I lost it. All right. Find the average value. That is f of c. F of c is the mean value, the average value. And we said f of c, the average value is 1 over b minus a, integral from a to b, of 1 over, or f of x d of x. So let's do this. Here we go. 1 over 4 minus 1 is 3, 1/3, from 1 to 4, 1 over 2x d of x. Now, you got a couple ways to approach this. You could set u equal to 2x, or you could do what with the 1 with the 2 in the denominator? Just bring it out here. Yeah, so if we brought the 1/2 out, that becomes 1/6 from 1 to 4, 1 over x d of x. Guys, what's the antiderivative of 1 over x? The what? I have not heard it. I heard it. The natural log of x. From 1 to 4. So that becomes 1/6. I'll write it all out so you can see it. That becomes 1/6 the natural log of 4 minus the natural log of 1, which is 1/6 the natural log of just 4. We okay? All right, here we go. Next problem. The volume V, so this is, look, I can already see it's a calculator problem. The volume V, how do I know that? Look at the function. You guys want to take the antiderivative of that? Okay, the volume V in liters of air in the lungs during a 5-second respiratory cycle is approximated by this volume, where T is the time in seconds. Approximate the average volume. What are you going to do? 1 over b minus a, the integral from 0 to 5 of that d of t. Use your calculator, see if you can get it. So it should be this. From 0 to 5, I forgot the 1/5 in front, of V, I'm just going to call it V of t, d of t. You're going to go to your calculator and just get that. Do you guys need to see me? Do I need to show you how to get the antiderivative in your calculator? You need that formula back? Sorry. So I would type that in right here, 0.1729x and then plus 0.1522x squared. Okay, thank you, Griffin. That's very kind of you. Minus 0.0374 x, x cubed. Thank you, I got it. That was the function, yes? Then I'm just going to get out. And I'm going to say alpha F2 Number 4, from 0 to 5. Doggone it. From 0 to 5 of alpha f4, that function I just typed in, d of x. So again, I just replaced the t's with x's, hit enter. And then what do I need to do? I need to divide that by 5. Because I'm asking for the average value. Okay. Next problem. So, we never had, so what this is a review PowerPoint that I made last year. Why don't you understand where this is coming from? We didn't have time. This is actually this is a question from a quiz I gave the students last year. We never got this quiz. But we have done problems like this as the worksheet to start, so I figure we need to go back through this. So, let's read it. It says, let g of x equal the antiderivative from that 0 to x of f of t d of t, where f is a function whose graph is shown below. This is the graph of f. So if you will, this is the derivative. Find g of 0. Guys, I replaced this x with 0. What's any integral from 0 to 0? Whenever it goes to from 5 to 5, from 6 to 6, it's always 0. Because there is no area under the curve. Okay? So when I say from part 2 here, from g of 4, I'm asking from 0 to 4, which means I'm asking for this area right here. Is that area going to be positive or negative? Negative. And that base is 4. That height is 4. Half of 4 times 4, negative 8. And then g of 8 would be from here plus this. So we know this is negative 8. This is going to be a positive. This is the area of a trapezoid, yes? So we got to find the area of that trapezoid. That's what? 1/2. What's the height? 4. And then the sum of the two bases. This base is 4. This base is 4 plus 2 is, so half of 24 would be, but remember, this is 12. This was negative 8, so it's negative 8 plus 12. 4. You're good with that part, right? That's geometry. These next parts give you a little bit of problems. Again, I want to point, yeah, you love that part. I can assure you that part is happening on the test. I can assure you all this is happening on the test. Okay, here we go. I said beginning, this is the graph of f. Think of f as your derivative. Find the largest interval where g is increasing. So this is the derivative of g. Okay? My derivative is increasing when its values are positive. Where is it positive? It's increasing from 4 to 8. Let's write that in. So I didn't ask this question. Where was our integral, where is our function g decreasing from 0 to 4? What's the next question? Find the largest interval where g is concave down. Okay. Concavity is determined by second derivative. This is first derivative. How can I know second derivative from first derivative? Ari?
Is it the zeros of that graph right there?
That would be where the derivative's 0. I'm asking for concavity.
Oh, so it's where it turns.
What turns? I think you're right. Okay, I got a question. This is the derivative graph, right?
Yeah.
What's the slope from here to here? Positive or negative?
Negative.
So isn't the derivative of the derivative the second derivative? So aren't all these tangents negative? So this is where it's concave down, concave up, nothing, concave down. So what's the largest interval? From 0 to 2. It's also concave down where? 7 to 8. Okay. All right, I think you were thinking this part. Identify any relative extrema. This is where the derivative is 0. Before that, it was, if the derivative is negative, that means it was decreasing, positive, increasing, decreasing, 0, increasing. This is a relative minimum at x equals 4. You don't know the y value. At x equals 4, I have a relative minimum. There wasn't doing anything, even though these derivatives are 0, I don't have what it was before or after, so I can't determine if it's a relative max or min. Yes? Determine the absolute maximum of G. I didn't ask for relative extrema, absolute maximum of G. Okay? The absolute maximum occurs where I have the most positive underneath the curve. Don't I get the most positive answer here at x equals 8? Because everything, look, negative, negative, positive, but it's still negative till about right here. Then it finishes with a value of 4. I know that because here's my endpoints. I found the critical number. See these values? Endpoint values. So the maximum is at 8, and what is the absolute maximum? 4. So at G of 8, the maximum value is 4. Where was our absolute minimum value at? G of 4. Let me pause for a second. Everybody just stand up. Just stand up for a second. Just take a break. Just stand up and chill. Everybody just stand up, chill. Okay. This is what we're thinking. My total distance traveled doesn't care about where I started. It cares about how. So see, look, running backwards, running to the left, running south, doesn't matter. So it's the absolute value of this plus the absolute value of this plus the absolute value of this. Isn't total distance traveled this formula? The integral of the absolute value of velocity, d of t. Okay, so what we need to do is we need to find the area of this triangle. I would actually break this. I wouldn't even do a trapezoid. I would say triangle, rectangle, triangle, triangle. Y'all with me? I need you guys to take a moment, everybody please, and find the area of each part for me, and then we'll write it down. We'll crunch on there. That triangle is 4.5. What's this little triangle? 1 times 3 is 3. What's half of 3? 1.5. What's this rectangle? It's what? It's a 1, 2, 3. It's a 4 by 3. What's it? So what? 12 plus, what's that other little right? It's also a what? 1.5 plus, I'm not going to answer that. That's a 1 by 4, so half of 4 is, why? Who said minus? It's total distance traveled. It's the absolute value. If it was position, you would do the positives and negatives. And I believe that gives me, is it 21.5? So now, second part, B, what is the particle's position at 10? You got to start with its initial position. What was its initial position? 5 minus 4.5 plus all this, look up here, plus all this, so how about 3 plus 12 plus 15 minus 2? Does that look right? That gives me 13.5 units. When does the particle reach its maximum position? When? At t equals, where? 9. Justify it, Brendan.
It's because that's where there's the most area.
The most positive area occurs. That's good enough for me. This was all moving to the left or down. Now I'm moving to the right again. This would be my maximum position because after 9 I go negative again. What'd you guys I think I'm gonna all right. Now, are we good with this? What's the antiderivative of u squared? 1/3 u cubed times 1/8. So 1/24. Replace u with 2x to the 4th plus 1 cubed. And don't forget that plus c. You like it? Good. You guys should be going, yes, I like that problem.
Yeah.
Yeah. Ugh. Well, let's just evaluate this for a second.
The U is X plus
You think so?
1. I think.
All right, let's see. So, Cookie says u is x plus 4. What's du then? 1 dx. But that doesn't get rid of that. You're not wrong, Cookie. Keep going with it.
Okay, so then it's
This is going to become square root of u.
But it's like u to the negative 1/2.
No. But you got to get rid of this x here.
Yeah. Well, if we multiply by 2.
No, Ari.
Solve the u equals x plus 4 for x.
So x then would be equal to u minus 4. You're going to take this u minus 4 and plug it in there for x. This is a big boy problem here. Or big girl problem, because we believe in equal rights in every aspect in this classroom. This is a safe classroom. Okay? So 2 times what's x? U minus 4. See, I have the video on. I got to be politically correct right now. I'm recording myself. Over the square root of u du. Okay. Let's distribute the 2 through and simplify. You guys feeling like you think you know where we're going? So this becomes 2u. Let's see here. Negative 8 plus 1 would be negative over. I'm going to do this because I know you know that's the same. Square root of u is the same thing as u to the 1/2 d of u. So we're dividing by a monomial. Simplify that bad boy. What's 2u over u to the 1/2? 2u to the 1/2 minus 7 u to the negative 1/2 du. Here we go. We're going to take the antiderivative now, aren't we? So 1/2 plus 1's 3/2. So u raised to the 3/2. 2 divided by 3/2, which is 4/3. I probably should have left myself room to write that. 4/3 u to the 3/2. Thank you. All right. Negative 1/2 plus 1 would be 1/2, so that's minus 7. I'm just writing it out so you can see it, over 1/2 u to the 1/2, which becomes minus 14 u to the 1/2 plus c. And then we're going to go back in and replace u with x plus 4. So if I did it right, I did. I know I did. I apologize. I don't think I can get it back either. That's a more higher level. I'd say it's a tougher U substitution. Okay. Your choice of how you approach this one. My suggestion is make U 5x. What's du? 5 dx. I don't have a 5, do I? So I'm going to put a 1/5 in front. It becomes 1/5 tangent of u du. Everybody agree with that? Everybody go to their golden ticket, please. So first page of test, true, false. Second page of test, matching. This is what's on the matching. All 22 derivatives plus the extra 2 I gave you of the a to the u and the log base a of u. I love how Maddie has those two written down that I said add them. And of the diff integrals, all but the last 3. So 1 through 16. Everybody hear me on that? All right? So the derivatives and the antiderivatives are going to be on the matching mixed up. You're welcome. But you feel good about them. There are a lot of easy points. Okay. What is the tangent of u? So I'm going to go 1/5. What is it? Negative. Can I change that to a negative? 1/5 ln absolute value cosine of u plus c. Well, hold on. What's u? So then you just go in and you say negative 1/5 natural log of the absolute value of the cosine of 5x plus c. Okay? I think I showed you before break, not think, I know. I showed you how, say you ever forgot, you would make that tangent of 5x, you'd make that sine of 5x over cosine of 5x. Good. I'd like you to do this one on your own. This one I recommend that you do what first? Divide out. It just makes life so much easier. So let's make this the antiderivative of what? X minus 8 over x dx? Yes? Everybody comfortable with that step? Okay. Can I pick on you? Thank you. What's the antiderivative of x? Love it. Minus, Pipe, what's the derivative of 8 over x? I'll help you out. 8, just think of it, what's the antiderivative of 1 over x? I've been doing it over and over. It's been my emphasization. It's how we started life today. That's right. The natural log of the absolute value of x plus c. Questions? This is one of those tough ones again. I'm thinking use x plus 1. Okay? Let's see. So du is just dx. So again, that doesn't help me here, except x equals what?
U minus 1.
Okay. And then we're going to plug that in. So now it becomes the antiderivative. And I'm not going to put in new boundaries yet. So it becomes x squared. What is x? U minus 1 squared minus 2 over u, and du replaces dx. Okay, what do I do next? Maddie, what should I do next? How do I simplify it? You're right. Square the binomial. Let's square that binomial. So that becomes what? U squared minus 2u. That would be plus 1 minus 2. Can I just go straight to plus 1 minus 2? Just go minus 1 all over u du. Let's take the u through, so it becomes the antiderivative of u minus 2 minus 1 over u d of u. So, and notice how I have not put in the new parameters. You guys want to change them to in terms of u? We might as well. So if this is x, what's 0 plus 1? So this is from 1 to, this is 2, 2 plus 1, 1 to 3. Let's go. Let's take the antiderivative. The antiderivative of u is 1/2 u squared minus 2u minus the natural log of u, absolute value of u, from 1 to 3. Okay, that's going to be a little bit ugly as we plug that in. I'm running out of time here. So what we would do is we'd plug in 3. Let's see here. 9/2 minus 6. I'll write it down. 9/2 minus 6 minus the natural log of 3. Let's see. 9/2 is what? 4.5. Minus 6 would be negative 1.5. Negative 3/2 minus the natural log of 3. Minus, if I plug in 1, that gives me 1/2 minus 2. What's a half minus 2? Negative 3/2. Notice how I put that in parentheses. Minus, what's the natural log of 1? I heard it. 0. So it's gone. So look. These cancel. I get just the negative natural log of 3. Woo! We got to get to the business calc real quick. Find the marginal cost function. If this is the cost function, what's the marginal cost function? It's derivative. So it's c prime of x. Well, okay. Just look up here. I'll walk you through it. Everybody look up here. The derivative of c would be this. C prime of x. Okay? Find c prime of 100. So c prime of 100 is 10 cents a unit. What does that mean? This is important. C prime of 100 means it would cost me 10 more cents to produce the 101st, the next item. Compare the C prime of 100 with the actual cost of the 101st. So the actual cost is what cost of 101 minus the cost of 100. Look how close they are. They're almost the exact same thing. That's why we like to go to marginal cost. C prime of 100 would say the cost of producing the next item The next item after 100 is the 101st item. It costs me 10 more cents. Questions over that thought process? Make sure you're able to explain it to me and show me on the test. I'm done.